And when you're talking about trays that may have 150 instruments plus in them, a tray like that would take, usually a technician that's maybe been there for probably at least 6 months, if not a year, right, to be able to properly assemble. And this is where I like to say that there's things that people do well and there's things that machines do well. And I think what we should do is allow people to do the things that they do well and allow machines to do the things that they do well. And in combining those two, we sort of get the optimal outcome of man and machine or woman and machine working together.
From the basement to the boardroom, from ideas to innovation, you are listening to the Beyond Clean podcast, the central nexus for the people, processes, and products that are pushing the sterile processing industry forward. Each week, you will encounter diverse perspectives from subject matter experts across the country and around the globe. Frontline technicians, CEOs, engineers, and entrepreneurs, with a common goal to help you fight dirty every instrument, every time. Whether you are tuning in for education or inspiration, we are glad you are here. Now, turn on those washers and turn up the volume. It's time to go beyond clean.
On this Vendor Spotlight, we speak with Braun Kiess, co-founder and chief sales and finance officer for RST Automation, LLC. Mr. Kiess is a successful serial entrepreneur, educator, and investor and brings over 20 years of experience from a diverse range of industries to RST. Braun sits on multiple corporate boards and is an adjunct professor of finance and entrepreneurship at Rutgers Business School, where his courses include evaluating new business ventures, venture capital analysis, and managing growing ventures at both the undergraduate and the graduate level. In addition to being a member of the Rutgers faculty, Mr. Kiess is a widely recognized expert on valuation and financial strategy. Braun regularly consults to Fortune 500 companies and IP-based startups on valuation. He holds a Bachelor's of Science degree in finance, summa cum laude, from Rutgers University, and he has his Master's in Business Administration degrees from both Columbia Business School and London Business School. So I love Braun's bio where he describes himself as a successful serial entrepreneur. And we here at Beyond Clean can definitely identify with that because it means innovation, it means disruption, and it means bringing new technologies to the market. And so today we're going to be featuring two products, one AIM tray assembly and then AIM peel pack. And we're talking about increased efficiency, increased quality, and really setting a standard and helping SPD departments perform more efficiently. And the part that I'm going to love talking about with Braun is increasing the amount of time that technicians have to inspect instruments.
You're listening to Beyond Clean, the global voice of sterile processing.
Joining us now is Braun Kiess, co-founder and chief sales and finance officer for RST Automation, LLC. And Braun, I've had an opportunity to see a number of videos of your products, and I haven't seen them firsthand, but I can tell you that I'm really excited to talk about it today. And before we get into the solutions that you have for the industry, I think we should talk about the company in general. Can you introduce RST Automation to our listeners?
Sure can, Justin. And hey, thanks so much for having me on today. So RST Automation, we're an innovative healthcare technology company that's really committed to developing systems that enhance the quality, efficiency, and effectiveness of the Sterile Processing Department.
Excellent. And I think one of the other things that your company is founded on is really good data that you can do something with. Is that correct?
Yeah, so data, I'd say, is definitely one of our strong points. It's something we do really well. Fundamentally, our core technologies that all our systems are built on are machine vision and artificial intelligence. And it's sort of by combining those two that we have developed the ability to optically recognize surgical instruments. Now, once our systems are able to recognize the instruments, then, of course, we can count them and sort them and manipulate them in various ways and use them to achieve different outcomes within the department. But one of the nice byproducts of all of our systems is that we get very accurate, very granular data from them, something we like to call actionable data. So this is data that's really first in its class in its respect to being accurate. So a lot of times we find that the data that management has to work with in the department is very flawed, let's call it, in numerous ways. And so because of of that, it's very hard to judge technician performance. It's very hard to manage outcomes and to, if you want to get involved in things like Six Sigma type processes, there's a lot of challenges in the current data reporting quality within these departments. And our systems really help fix that and allow managers to do their job better and more effectively and implement Six Sigma type processes should they desire.
Well, we know that really has a great deal of impact on quality and efficiency, especially when you're talking about Lean and Six Sigma concepts. It's about taking a lot of the unnecessary or maybe even manual processes out of the equation so that you get a more consistent result and a more efficient process. So we know that this industry is starved for data. We've had countless episodes on various different topics on Beyond Clean that have talked about the need for data, and also how do we empower managers to be able to make decisions. And many times we need that data to make those types of decisions. You started to talk about the challenges in existing sterile processing departments, and I think that's tying very closely to why you're bringing this technology and this solution to the market. But what were some of the other problems that you saw that you could address in the industry to just help make significant improvements as a disruptor and an innovator?
Sure. So when we looked at the different processes involved in the sterile processing department, what we saw in general is just a department that is very labor intensive. Its processes are very error prone. We see departments that generally are understaffed, right? The labor they need is unavailable. If it is available, it's oftentimes not properly trained. This, results in a lot of overtime in a lot of these departments. And quite frankly, more errors than there needs to be because people are just overworked, right? They're working a lot of times multiple shifts. They're working very long shifts, and this affects the quality of the outcomes. And as we know, right, sterile processing is a critical supply center to the operating rooms. And when you have errors in this department, it really affects, the hospital in a very meaningful way. So what we fundamentally look to do is use some innovative technology to improve these outcomes and improve these processes and help technicians really do their jobs better. Right, do their jobs more efficiently and more effectively. And I think fundamentally what we do, which is sort of a paradigm shift for the industry, is fundamentally we structure unstructured processes. So, for example, Justin, if you were to take the tray assembly process in the sterile processing department and you were to have 20 technicians assemble a tray, you're likely right now to have that tray assembled 20 different ways. Right? Each technician is just going to do it a little bit differently. And that's okay, but from a process perspective, it's a nightmare. So what we're fundamentally doing with our tray assembly system, for example, is we're structuring that process. Same thing on the peel pouch side, right? When you have a technician now or technicians that are doing peel pouches, it's a very disjointed process. Each technician does it a little bit differently. And again, our peel pack system now structures that process. So you have a consistent process and you have accurate data reporting coming out of that process.
Boy, are you ever right about that variability, especially when it comes to instruments on a stringer and the communication and perception between the OR and SPD. And I know we're going to talk about that, so I don't want to jump the gun too much there, but that is a perfect example. And I appreciate you characterizing sort of that environment, because I will tell you, our chief medical officer has said over and over, you take a complex task, you repeat it over and over, you're going to have error rates. And I think that a lot of times sterile processing managers and frontline staff take it personally, but inherently it's built into what we should expect. And so giving the technology to help support that and reduce those errors is really critical to improving the quality output and the interaction with the operating room. So why don't you tell me this? I'm sure there are companies that are trying to bring data and control some of these processes that are subject to human error, but what differentiates you from, say, another company that is trying to solve similar problems?
Well, I think what fundamentally differentiates us is our technology. So we really have no direct competition in this space, primarily from our intellectual property, to be honest. So our technology is proprietary. It's all been developed in-house, so we develop all the software and the hardware ourselves. And over the years, we've developed a lot of intellectual property, a lot of patents around our technology. So that combination of machine vision and artificial intelligence that allows us to optically recognize instruments is really first in class. So in general, there's other methods out there to identify instruments instruments or to recognize instruments, but they all have significant shortcomings. And we feel that from a cost perspective, from a quality perspective, from an implementation perspective, our technology is by far the most accessible and makes the most financial sense for most organizations. So that's what I think fundamentally differentiates us, is our technology and our application of it to different processes that we've seen that need help, right, in the departments, such as peel pack assembly, tray assembly, and the management of excess instrument inventories.
All right, that's great. And you mentioned the finance piece of it. I heard you throw that in there. So how do you help your prospective customers see the return on investment here?
So we have a very consultative sales approach. We work really closely with the facilities to analyze their data, to analyze their tray volumes and their types of trays. And by looking at their data, we can see exactly what type of benefits they could expect to see in implementing our system. So based on the volume of peel pouches that they create, the volume of the trays that they process, the types of trays that they process, the depth of their excess instrument inventory, by looking at sort of all these different aspects, we can calculate very robust return on investment models for the facilities, and our systems have been in place at many facilities for years now. We have very good data coming out of them. We know if you implement these systems, what will happen, and we can show that to you, and if you use them, they work.
All right, Braun. So what's interesting here is a challenge that many managers and directors have expressed, not only behind the scenes, but very outwardly and in conversations with us, is the fact that sometimes quantifying what I think you're describing is soft costs to get the C-level, or at least whoever holds the budget or approves the budget, to understand that these soft costs have hard data that will show that return on investment. But how do you address that when some of it is really a soft cost and they're bringing in a product that has a price tag on it?
Sure. So we look at it both on the hard cost saving side and on the soft cost saving side. So coming from a finance background, this is, the type of conversations I love to have. And at the end of the day, we can all agree, I think there's a lot of areas of soft cost savings, but we need to, again, allow a C-level person to make a financial decision on this with some hard cost savings. And that's something we're able to do with the efficiency that our systems bring to various processes that they're employed in. For example, if we're looking at tray assembly, right, we generally, our tray assembly system will typically improve quality, number one, but will also improve throughput, sometimes in excess of 50%. So you're looking at a much more efficient process that can be directly tied to reductions in overtime, the redeployment of staff to different areas in the department, or the addition of more operating rooms without increasing staff levels. So we can directly tie, right, hard cost savings and productivity to the cost of our systems and show the return on investment, things like net present value and internal rates of return. We can calculate those very specifically based on the data we have and the volumes we see at the facilities, and give the C-level folks or whoever's holding the purse strings some very great insight into why this is such a great investment and why our systems are such a great investment. Now, on the soft cost savings, again, those are the things that are really hard to quantify. And when you talk about things like quality and reducing tray errors, right, our tray assembly system has been shown to eliminate errors in 3 critical categories. So missing instruments, incorrect instruments, and incorrect stringer order of instruments. We eliminate those error categories. How much money does that save the facility? Again, that's a soft cost savings. It's very hard to quantify, but I think we can all agree that when trays have the right instruments in them in the right order and in the right place, that makes surgeons happier. It makes patients safer. You're reducing operating room delays, which are certainly very costly delays. So I think we generally get agreement on the soft cost savings side, but it's again a hard category to quantify. But the hard cost savings we can, and that's all driven strictly by the increases in productivity that we see from the systems. So with regards to the return on investments, what's really neat is that we can actually see the improvement happening over time with the technicians. And this data is, again, it's kind of the first time it's been available. But remember, our systems track tray assembly times on an instrument-by-instrument basis. And we'll see consistently that technicians will start off processing instruments on our systems maybe at a rate of 15 to 25 seconds per instrument. And over time, right, over the course of a few months, as they get more comfortable with the system and learn how to operate it more efficiently, we'll see those times drop to 10 seconds and oftentimes down to as low as 6 or 7 seconds per instrument consistently. And that's just really sort of interesting data. It's really neat data to see. And again, it's very trackable, very identifiable, very traceable, and very specific. So we really enjoy the sort of data reporting that comes out of that and how we're able to tie that into the return on investments for the facility.
Well, you really got my attention with reducing tray assembly times often by 50% or more. That's substantial. That is quantifiable. And I know that anybody who's out there putting trays together is going to love hearing that, and their productivity is going to go up. That's a big win, not only for the manager and for the frontline technicians and the staff, but for the entire department. It just is going to put them in a much more positive light. And so I want to go right into the part that I teased earlier, which was the stringed instruments. Can you walk us through how the system strings instruments so that you get consistency, that they're not 20 different technicians and 20 different ways to assemble the tray? Like, what does that look like in practice?
So AIM tray assembly, and by the way, AIM stands for Assisted Instrument Management, and currently all three of our products, tray assembly, peel pack, and storage, all fall under the AIM family of systems. But AIM tray assembly is, again, a system that really helps technicians just assemble trays much more accurately and much more efficiently. And the analogy I like to use is it's really empowering the techs to do their jobs better, right? So it's sort of like if you imagine somebody who was assembling something using a screwdriver, and then all of a sudden we sort of come in and instead of a screwdriver, we give them a power drill. And that's sort of the difference that you see in terms of productivity and reduction in fatigue, right? Because you can imagine, right, sitting there turning a screwdriver all day is a very tedious process. Your hand hurts. It's not very efficient. So what our system does is it's that power drill. All of a sudden, zoot, 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 right? You're moving right along. Your hand doesn't hurt anymore, and your job's much more enjoyable, and it's getting done much more accurately too. So quality goes up and efficiency goes up. We've spent a lot of time watching a lot of video footage of sterile processing departments. And what you'll typically see with the technician when they assemble a tray is they'll walk over their station with the tray, they dump the instruments out onto the workstation, and then they start pre-sorting the instruments into piles of like instruments. And this pre-sorting actually takes quite a bit of time. And that pre-sorting is one of the areas where we pick up a lot of our efficiency. So with AIM tray assembly, if a technician walks up to our tray assembly system, the pre-sorting is completely eliminated. So they no longer have to pre-sort the instruments. They can just take the instruments from that tray and start feeding them randomly into the system. As they're feeding them in, that system will take the instruments, it'll recognize them, it'll check them off on the count list. Obviously, if the technician puts in an instrument that doesn't belong right in that tray, the system will kick it back, say, hey, that instrument doesn't belong in here. If the count's full and they try and put in another one, right, it'll kick it back and say, hey, we don't need any more of these. The count's full. So they're able to process the tray in random order. If it's a strung instrument, the system will actually take the instrument in, it'll ID it, it'll check it off on the count list, and it will actually assemble the stringer for the technician. So it'll take those strung instruments that are fed into the system in random order and put them in the correct order. So we pick up a lot of efficiency in that process, a lot of productivity there. Another area there's a lot of productivity gained is with regards to missing instruments. So let's say the technician has finished the tray, they fed every instrument in, but the tray is not yet complete. Prior to using our system, what a technician would do if they realized they were missing an instrument is they would leave their workstation, they would go find that instrument, and then come back to the workstation, continuing the tray assembly, and then they realize, a few minutes later they're missing another instrument, they leave the workstation again, they go get that instrument, they come back. A lot of time gets added to the tray assembly process using the old methods in the handling of missing instruments and the retrieval of missing instruments. What's nice about tray assembly is at the end of the tray assembly process, if there's instruments that are still missing, the technician can just hit the needed list on the screen and print out sort of a little shopping list, if you will, of the instruments that are needed to complete the tray. What's also really nice is we can tie instruments to storage locations. So whether you're using bins or drawers or Hanel type systems, which we also interface our systems with, we can tie those missing instruments to locations, or we can send a job to a Hanel system to make it very efficient for the technicians to retrieve those instruments in one trip. And so that's another area where we pick up a lot of efficiency in the tray assembly process.
Yeah, that seems huge to me, especially when you start interfacing with other technologies that also bring efficiencies. Like the aggregate impact is greater than the sum of the individual parts. I can see where that would come together. And especially with the whole backup board, a lot of times that backup board is not always well maintained. Instruments don't go back into the right bin, and being able to organize it and go back for just everything you need all in one and then feed it into AIM, and you still get it in the right order. Like, that just seems huge to me. And so I got to think there's also some impact on training and education, and even just the data that comes around to guide the decisions that are made in the department.
Yeah, absolutely. So with training and education, it's a very time-intensive process for many facilities to properly train technicians. And when you're talking about trays that may have 150 instruments plus in them, a tray like that would take usually a technician that's maybe been there for probably at least 6 months, if not a year, to be able to properly assemble. And this is where I like to say that, look, there's things that people do well and there's things that machines do well. And I think what we should do is allow people to do the things that they do well and allow machines to do the things that they do well. And in combining those two, we sort of get the optimal outcome of sort of man and machine or woman and machine working together. And humans are very good at inspecting and testing instruments, okay? That's a very fine motor skill. It involves a lot of knowledge. It involves, eyes and hands and things that would be virtually impossible for a robot to do. Machines are very good at identifying things and counting things and sorting things. So we say, look, allow our machines to do what they're good at. They're good at identifying things and counting things and sorting things, and let people focus on what it is that they do well, inspection and testing. And that's sort of one of the fundamental ways that we shift the paradigm of tray assembly by structuring this unstructured process. So when we're feeding instruments into the system, it's now a structured process. The instruments are being handled one at a time. So they're being inspected and tested one at a time, which it's better from a process perspective, right? It's the way it's supposed to be done versus when we watch the videos in a lot of sterile processing departments, we see technicians picking up 5 or 6, scissor-like instruments. They'll pick up 5 or 6 at a time and inspect them all at once. So we just put in a much fundamentally higher quality process in the way the process is structured using tray assembly. And it also really helps with training and education. To your point, these large trays, they take a lot of training and education to be able to properly assemble. We have instances where we have taken folks with no tray assembly experience whatsoever, no sterile processing experience for that matter whatsoever. We've trained them on our tray assembly system for a week, and the next week they are in there assembling 150 instrument trays accurately and efficiently. And that's a huge change from having somebody that might need 6 months to a year's worth of experience to be able to assemble that tray. So there's also a training mode on the software. So instead of automatically identifying the instrument, the system's put into the training mode, it will ask the technician what instrument it is. It'll present them with 4 choices, and the technician selects one, and it'll keep score. And you can run reports on that and see how technician's knowledge is improving over time with the instrumentation. It also provides a lot of ancillary data to the technician where they can look at, if they're not sure what instrument it is, they can pull up pictures, they can look at catalog numbers, right, et cetera, et cetera. So there's a lot more detailed information that they can get into in the interface that helps them actually learn the instrumentation. So that's part of our goal, is to help educate technicians on the instrumentation as well. So the learning and education component, or training and education component to our systems, we think is also a really nice benefit. And to that end, if you're using a system like tray assembly, it a lot of times eliminates the need for preceptors, because again, you can rely on the system for the identification as well as the counting and sorting, and leave more time and energy for the technicians to spend on that critical component of tray assembly, which is the inspection and the testing.
All right, so let's talk about AIM Peel Pack, because tray assembly is not the only product that you have, and this is really cool. And I want to encourage anybody who's listening to this podcast to go to your website and see it in action. Both are very cool, but the Peel Pack is going to garner some serious attention if you haven't seen it already.
Yeah, we're really excited about this product. We just launched sort of the beta version of it last year, and it's been really well received. If you talk to most sterile processing techs who have to do peel pouches, they don't like doing it. It's not a job they look forward to doing. But yet, a lot of facilities process a really tremendous volume of peel pouches, and would probably do even more if they had a better way to do them. So again, that's sort of what we've done with Peel Pack, is help to alleviate that pain point for technicians. If you looked at the Peel Pack process in most facilities prior to our technology, again, it's just a very disjointed, sort of labor-intensive, error-prone process where you have technicians first needing to look up instruments in their systems and determine what size pouches, and then find those pouches and get the right size and cut them to the right length, and then go back and print out the labels, and all these different sort of sequential activities that need to happen. Versus with our system, you simply walk up to the system, you put the instrument down on our surface, the system identifies the instrument, it automatically selects the right size bag, it dispenses it to the correct length, it cuts it, it seals it, at the same time it prints the label. You can tell it to make 10 of them at a time if you want. You could tell it to double pouch them if you want, in which case it'll simultaneously dispense the correct size bag for the instrument and then the next size up, so you could put that pouch inside the other. So we've seen, again, tremendous reductions in peel pouch times by as much as 75%. So reducing the time it takes to make a peel pouch by as much as 75%. And it's also now structured. Once again, the process process is structured, a peel pouch gets made the same way every time for the same instrument. And that consistency has never really been there before.
Yeah, I think the waste is something that is really cool about cutting them to length, because, how many times you just have some standard sizes, or you're cutting them in your cells and it's not really, the right exact size. Like, I can see where the science of this and the information that's in the system really has got to have, you talk about efficiency a lot, but we've been talking about efficiency for the human side. But this is the first time we've really talked about efficiencies and waste reduction in terms of the actual materials that are being used.
Yeah, and I think there is a lot of benefit here on the material side, and it really is in two dimensions. So the first comes from just the savings of material in general, because now you're getting the correct size material every time. And again, if you watch, videos of peel pouch assembly, you'll see a lot of times, we're human, right? Sometimes we cut the material to the wrong length, or it's too long, or it's too short, and we're trimming it back, or we've got to throw it away completely and do it again. So there's just a lot of material wasted because, again, fundamentally the process isn't structured. Now we get the correct size pouch for the instrument every time consistently. So now that the process is structured, it's consistent in the amount of material being used, and it's always at the right size. So that's the first dimension. The second dimension is the type of material being used. So our peel pack system uses all roll material. So a lot of facilities right now probably use some pre-sealed pouches. We basically eliminate the need for any type of peel pouch material besides rolled material. So you can really switch sort of all of your peel pouch purchasing to the rolled material, which in general is much cheaper than the pre-sealed pouches. So there's a reduction in that dimension just on the material cost, because we're using a less expensive material. And then again, on the first dimension in that, we're just using less of that material.
Okay, so here's what your customers are saying. And this is a quote from Corey Nessman when she was at the hospital for special surgery as the assistant VP for Central Sterile Processing and DME Support Services, now at Cedars-Sinai. She says, AIM enhances our tray assembly process and provides us with actionable data for process improvement and operational management. With AIM, we have seen significant decreases in per instrument processing times and incorrect or missing instrument errors. In fact, the thousands of trays processed using AIM have had 0 missing or incorrect instrument errors over the last year. AIM also helps train the staff and get them up to speed more quickly and with less oversight. Because of all of this, our AIM systems have become a critical resource that we rely on every day. And honestly, I know these are a lot of the themes that you talked about in terms of the training and everything else, but it always is great to hear it from somebody who's actually used your products. And I know there's also an HPN article that references you, and you have a white paper. Can you talk about, some of the other materials that the listeners should either be finding on your website or in the bonus content for this podcast on our smartphone application, so that they can find more information and share it either with their colleagues or the decision makers at their facilities?
Sure, Justin. So it's always nice to hear, the voice of the customer, and we really do try and to talk to our customers and listen to them, and ultimately, design systems and products that meet their needs and, help relieve pain points for them. So yeah, Corey has just been wonderful to work with. Another customer of ours is Fairview Health up in Minneapolis. They employ our technology in their department. They actually won HPN's Sterile Processing Department of the Year this year here in 2020. And Lori gave us a nice shout out in that article. And again, it's, her and her team have just been wonderful to work with. And we like to think we had a small part in, the amazing things that she's done at that facility and that they've done in sterile processing. You mentioned the white paper, and we do have a great white paper that we've written, based on customer data and experience. It's available for download on our website. So you can go to rstautomation.com and you'll be able to download our white paper there, as well as see demonstration videos of our products. And the white paper just sort of walks through the efficiencies that have been, recognized, and the quality improvements and the training and education and sort of all the things we talked about. This white paper is currently was written for their tray assembly. We're working right now on a white paper for peel pack. But again, the tray assembly system white paper just really highlights the areas we've talked about, what our customers are seeing in terms of productivity increases and quality improvements and training and education and technician accountability and, other actionable data reporting and all those things we've touched on. So it's a great read for anybody who's interested in learning more.
All right, excellent. So as you say about learning more and getting interesting information and supporting data and customer testimonials, how can listeners engage and learn more or reach out to you with questions, etc.?
So again, our website's a great place to start, but feel free to drop us an email. If you want to get more information or have any questions, you can send us an email at info@rstautomation.com. That's Robert Sam Thomas automation.com, or feel free to give us a call. Our phone number is 917-633-6050, and we're happy to answer any questions. Again, we have a very consultative sort of sales process, and we're happy to talk to you about what your challenges are and what we can do to help you.
Yeah, I just love the fact that, as you mentioned in that consultative process, that you'll analyze some of the data that they have today and help project that return on investment like we've been talking about earlier in the program. And so what a huge value that is to be able to give to them, because it's all about making the case. And anything that you can do to put good information, good data, things like return on investment at times when budgets have never been tighter in hospitals, it's going to be such a resource to the managers and directors that are looking at technologies like this. So, Braun, you did a great job today, and I really appreciate you coming on Beyond Clean to talk about the AIM assembly and peel pack solutions.
Well, hey, Justin, no, thanks so much for having me. We really love what Beyond Clean's doing for the industry, and we really look forward to continuing to work with you guys.
That was Braun Kiess, co-founder and chief sales and finance officer for RST Automation, LLC. And this vendor spotlight highlighted a brand new technology to the market focused on improving the quality, efficiency, and effectiveness of sterile processing department processes. And specifically, some things that really I took away were the fact that AIM tray assembly reduces assembly times often by 50% or more, which is substantial. But then with the AIM peel pack solution, they've reduced peel pack assembly by as much as 75%. And with that time, you have more time to do your job and inspect instruments. And we know how busy things get, especially after 10 a.m. when everything starts coming down and ramping up. And being able to do a quality inspection and creating more time is so key. And our chief medical officer, I remember asking him on one of the very early episodes when we spoke with Dr. Peter Nickel, I said, if we bring in the technology, does that mean we need less people? And his exact response was that, no, we don't need less people. We can have people focusing on the aspects of the job that really matter, like instrument inspections. So critical. They've got a white paper. You can head on over to their website, rstautomation.com, and there you can request the white paper to get more information. If you've downloaded the Beyond Clean smartphone application, you'll be able to get some bonus content, which will be product information on the AIM tray assembly and AIM peel pack solution. So you'll be able to get more information there. You can also find it on their website. You can email them at info@rstautomation.com with your questions. Follow them on LinkedIn as they continue to innovate. And then finally, one of the biggest things that Braun said at the end is that consultative nature. And so you're going to need to be able to bring an estimated return on investment to your leadership if this is a type of technology that you want to consider implementing in your hospital or in your department. And what's great is Braun and the team at RST can help you analyze the data that you already have to be able to project that return on investment. So very exciting show today, but that's going to do it for this vendor spotlight. As a reminder, you can help support Beyond Clean by subscribing on iTunes, Stitcher, Google Play, Spotify, or downloading our brand new smartphone application. We'd certainly appreciate a rating and a review because your feedback is important to the show. And if you have any topics that you'd like us to cover on a future episode, just send an email to info@beyondclean.net. Thank you for listening to this vendor spotlight on Beyond Clean.